Okay, so problem 11. It's a question of electing 3 officers for a club of 13 members. And it's important to note that the 3 offices are different. There's a president, vice president, and secretary. So, as always, the first question is this a permutation problem, basically, or a combination problem? And because the 3 offices that are being elected are distinct offices, it's a permutation problem. We'll come back to that in a minute, but it's a permutation problem, and it's 13 choose 3. So when I say 13, that refers to the 13 members, and that always goes right in front of the P. And choose 3, we're choosing 3 people out of the 13 candidates. So it's 13 choose 3 in a permutation problem, and that always equals, there's just the formula, and it's 13 factorial divided by 13 minus 3 factorial. And so that's just 13 times 12 times 11, or if you prefer, 13 factorial over 10 factorial. Now, let's say that instead of electing a president, a vice president, and a secretary, you're simply electing, or the group's electing 3 directors. So they're each going to hold the same title. You're going to have a director, and another director. So in that case, it's not a permutation problem because, as the textbook would put it, order doesn't matter. Or to put it another way, the offices are indistinguishable from each other. So in that case, it's a combination problem, which would be 13 choose 3, but you'd have to use the formula for combination. So it would be 13 factorial over 3 factorial and 13 minus 3 factorial. And that, of course, is, well, interestingly, let's go back. You can still use this. It would be 13 times 12 times 11, but instead of that being the sole answer, you have to still divide by 3 factorial. So that's it.